All right, here we go. So we have angle 5 congruent to angle 3 as our given. I'm sorry, angle 5 congruent to angle 6 is our given. We're trying to prove that 4 and 6 are sup. Okay, so how do we do this? Well, I'm going to go ahead and just write down my statements and reasons. That's the first step. And then I'm going to label my statements. I'm going to write down my given, angle 5 congruent to angle 6. This is given. Okay, so now what do we do? Well, we can go ahead and turn this into equation if we want. Would that be helpful? Yeah, I think that would be helpful. So let's go ahead and turn the congruency statement into equation. So it's going to become measure angle 5 is equal to measure angle 6, and then the reasons def of congruence. Now what do we do? Well, if we look at the figure, and if you see this in a figure, you can say that angle 4 and angle 5 are linear pair given from the figure. Okay, so if you see this, right, where you have two angles that are adjacent and they form a straight line, we can go ahead and say angle 5 and angle 4 are linear pair. And that's given, and you could say from the figure. Okay, given from the figure. Okie dokie. So once we have linear pair, then what can we say? Well, now going back to our proof sheet, right? Where does it say if I have linear pair? I could say something. Well, here it doesn't, here it doesn't, here it doesn't. None of these say linear pair, except for this one here. If we have two angles form a linear pair, then they're sup. Okay. So that's the sup theorem. So I'm going to say 4 is angle 5 and angle 4 sup, and that is the sup theorem. Okay, great. So now what are we trying to do? We're trying to say angle 4 and 6 are sup. Okay, so how do we do this? Well, now what can we do? Well, from sup, right, we can go ahead and use the definition of supplementary angles, create an equation, and then try to substitute to our proof statement. Okay. So definition of supplementary angles, if we have that two angles are sup, then we can say angle 1 plus angle 2 is equal to 180. So that's what we're going to do. We have two angles sup, so we're going to say angle 1 plus, angle 5 plus angle 4. So measure angle 5 plus measure angle 4 is equal to 180, and that's going to be our that's definition def of sup angles. Okay, so that is that. Now what? Okay, so now we have these two equations here. We have this one on step 2, or statement 2, and we have this one on statement 5. Right? So what am I going to do? I'm going to do a substitution. Right? So once we got all of our equations, we're going to go and substitute, and I'm going to take this measure angle 6, and that equal sign means I could put it anywhere I see measure angle 5. And do I see measure angle 5 in the other equation? Because we cannot substitute into the same equation. We need to substitute into a different equation. And yes, I do. I see a measure angle 5 right here. So I'm taking that 6, measure angle 6, and I'm putting him right there. Okay, so statement 6 is going to be measure angle 6 plus measure angle 4 is equal to 180, and that's going to be substitution. Now from here, what can I say? Well, this equation means that angle 4 and 6 are sup. That here is our definition of supplementary angles. The way the definitions work is if you have the two angles are sup, you can write this equation. We did that in this proof. Right? Definitions, though, also go the other way. If we have the equation, we can go ahead and say they're sup. Okay, and we have an equation for 6 and 4, so we can say 6 and 4 are sup. And I'm going to go ahead and do that. So angle 6 and angle 4 sup. And that's going to be the definition of supplementary angles. And hey, that's our proof statement. So we are finished.